What are cathode rays?
Electron beam in an evacuated glass tube.
What are cathode rays?
Electron beam in an evacuated glass tube.
What is a Celsius scale?
Temperature scale on which the freezing point of water is 0 degrees Celsius and the boiling point 100 degrees Celsius.
What is a Celsius scale?
Temperature scale on which the freezing point of water is 0 degrees Celsius and the boiling point 100 degrees Celsius.
What is the buoyant force?
The reduction in weight equal to the net upward force of a fluid.
What is a candela, CD?
Unit of measurement of luminous intensity.
What is an antenna?
Used to transmit or receive electromagnetic radio waves.
How would lasers produce fusion?
The second method of producing fusion is called inertial confinement. Tiny glass, plastic, or metallic spheres containing about 10 mg of deuterium-tritium. Fuel mixture at high pressure are bombarded on all sides by extremely powerful lasers. The lasers vaporize the sphere, driving a strong inward shock wave that compresses the fuel enough to create fusion. The National Ignition Facility, located at Lawrence Livermore Laboratory in California, has been under construction since 1997. The design goal is to create a 2 megajoule flash of ultraviolet energy that hits the target from 192 separate beamlets. All of the beamlets must strike the target within a few picoseconds. In January 2010, the laser beams delivered 700 kilojoules to a test sphere, heating the gas inside to 3.3 million kelvins. It takes hours for the lasers to cool enough to deliver another pulse. The engineering goal is to deliver one pulse each 5 hours. Before deuterium-tritium fusion fuel can be used, neutron shields have to be built to protect the lasers. There are no accepted engineering plans to convert the energy released to electrical energy. One proposed method is to surround the bead with a blanket of liquefied lithium that would be further heated by the energy released.
What is astrophysics?
Study of how astronomical bodies, such as planets, stars, and galaxies, interact with one another.
What is the closest fusion reactor?
The Sun. In stars like the Sun, the principal reaction is called the proton-proton cycle. That was first described by the German-American physicist Hans Bethe. 1906 to 2005, in 1939. In the first step, two protons fuse into a deuterium, 2H, nucleus. The deuterium has a proton and a neutron, so the second proton changed into a neutron, releasing a positron and a neutrino. The positron annihilates with an electron, producing two gamma rays. In the second stage, the deuterium fuses with another proton to produce helium-3, 3He, plus a gamma ray. In the Sun, the third stage is primarily a fusion between two 3He nuclei producing 4He plus 2 protons. So the net reaction is an input of 4 protons and an output of 2 4He plus 6 gammas and 2 neutrinos, as well as a lot of energy due to the loss of 0.7% of the mass of the protons. In order to accomplish these reactions, the protons must be moving with a large amount of kinetic energy, the equivalent of a temperature of about 10 million kelvins.
What is atomic and molecular physics?
Study of single atoms and molecules that are made up of these atoms.
Can fusion be used for peaceful purposes?
The energy released in a fusion reaction could be captured and converted into electrical energy. The difficulty in creating a fusion reactor is confining the reactants. Typically deuterium and tritium nuclei, at temperatures needed for fusion. There are two approaches, magnetic and inertial confinement. Most effort has gone into magnetic confinement, where the positively charged nuclei are trapped in evacuated regions containing strong magnetic fields that keep the nuclei from colliding with the metallic walls of the equipment. The swarms of charged nuclei, a plasma, must then be raised to very high temperatures and held at that temperature long enough for fusion to take place. So there are three variables: number of nuclei, their energy or temperature, and the confinement time. The product of these three variables determines whether or not fusion will occur.
What are fusion weapons?
even before the nuclear bomb was completed. Some physicists at Los Alamos started work on what they called the super, a weapon based on fusion. After the war was over, there were heated discussions, both scientific and political, about the wisdom of developing a new, even more destructive weapon. Due to tensions in the Cold War, both the United States and the Soviet Union embarked on programs to create these weapons, informally called hydrogen bombs. The United States tested such a weapon in 1952, the Soviet Union in 1955. Britain, China, and France are known to have tested fusion bombs. Some aspects of fusion weapons are known while others are still secret. What is known is that the bomb starts with a uranium or plutonium implosion bomb with deuterium and tritium gases inside its core. The neutrons released by the fusion increase the fission of plutonium or uranium, boosting the efficiency of the fission device. The energy released is transferred to a lithium dihydride fusion fuel in a process that remains secret. That undergoes fusion, and the energy released causes fission in a surrounding layer of natural uranium. The Soviet Union exploded a fusion weapon that released the equivalent of 50 million tons of TNT. The most recent effort on weapons development is to decrease the size of the weapons so they can be deployed in smaller delivery rockets.
What are cathode rays?
Electron beam in an evacuated glass tube.
What is angular velocity, CO?
Equivalent of velocity for rotational motion.
What is an arrow of time?
The forward direction of time is the one in which entropy increases or remains the same.
What is an antinode?
Locations in a standing wave where there is the largest amplitude caused by constructive interference.
What is an atomic mass number?
Number of protons and neutrons in nucleus.
What is carbon dating?
Method of dating objects by measuring relative amounts of radioactive and stable carbon in them.
What is the Archimedes principle?
An object immersed in a fluid will experience a buoyant force equal to the weight of the displaced fluid.
How are particles accelerated to very high energies?
The two highest energy particle accelerators are the Tevatron at Fermilab, near Chicago, and the Large Hadron Collider, LHC, at CERN, European Organization for Nuclear Research, near Geneva, Switzerland. Both machines accelerate and store protons moving in circular paths in a metallic tube, called the beam line, from which all but minute amounts of air have been evacuated. Beams of particles circulate through the tube in both the clockwise and counterclockwise direction. The beams intersect at several places around the circle so that the particles can collide head-on. Many superconducting magnets bend the paths of the particles into the circle, while other magnets focus the particles into small beams. Electric fields created in high-power vacuum tubes provide the accelerating forces on the particles. In particle accelerators, energies are measured in electron volts, eV. 1 eV is the energy a particle obtains by being accelerated by a 1-volt potential difference. Modern accelerators give particles energies of hundreds of MeV. Mega electron volts, or GeV, billions of electron volts. The Tevatron creates collisions between protons and antiprotons, each giving an energy of almost 1,000 GeV, resulting in an energy of 2 GeV when the two beams collide. In the LHC, both beams are protons. The design energy is 7 GeV in each beam for a total collision energy of 14 GeV.
What is brass?
An alloy that is typically 80% to 90% copper with zinc.
What is a calorie, cal?
A unit of energy that is used both to measure both thermal energy and heat.
What holds the quarks together in a proton or neutron?
Eight different massless force carriers called gluons exert the force that holds quarks together. Gluons are members of the boson family. Bosons have integral spin while quarks, electrons, and neutrinos have half-integral spins and are called fermions. Bosons can be created or destroyed, while fermions can be created only if an antfermion is also created. A single fermion cannot be destroyed unless an antifermion is simultaneously destroyed.
What is a Celsius scale?
Temperature scale on which the freezing point of water is 0 degrees Celsius and the boiling point 100 degrees Celsius.
What are brittle materials?
Usually break when under tension rather than compression.
What is the latest fusion reactor research project?
The ITER reactor project is international in scope, including the United States, Russia, the European Union, India, Japan, China, and South Korea. The plan is to spend 10 years in construction and 20 years in operation. No electrical energy would be generated. That would require a more advanced reactor. Using 0.5 grams of deuterium-tritium fuel. It is designed to produce 500 megawatts of energy over 1000 seconds. For the first time in a fusion reactor, more energy would be produced than needed to run the reactor. In May 2010, contracts were signed to construct the first buildings in the project that are sited in the south of France. Fusion reactions are scheduled to begin in 2018.
What is a British thermal unit, BTU?
Unit of energy often used to measure heat in homes and industries.
How are the results of collisions in accelerators detected?
A collision between two protons or a proton and antiproton can produce a large number of particles of different kinds. The task of a detector is to find the direction in which each particle is going, find its charge, momentum, and energy, and identify it. Detectors are huge devices. The CDF Collider detector at Fermilab weighs 5,000 tons and is 12 meters, 39 feet, in each dimension. It is operated by a collaboration of about 600 physicists from 60 universities and organizations. Atlas, a toroidal LHC apparatus, at LHC is even larger. It weighs 7,000 tons, is 44 meters, 144 feet, long and 25 meters, 82 feet in diameter. 2,000 physicists are involved in building and operating this experiment. In both detectors, position detectors locate the particles close to where they are produced in the beam line. Somewhat farther away from the beam line, a strong magnet deflects the paths of charged particles. Outside the magnet are additional position detectors and finally detectors that measure the energy of the particles. The curved paths charged particles take in the magnet are used to find their charge and momentum. Each collision can produce billions of pieces of data, only a small number of which are interesting. Electronic circuits and fast computers use data from the position detectors to decide whether the set of data are interesting enough to be recorded. Atlas produces 100 megabytes of data each second. The entire LHC produces 4 gigabytes of data each second. Enough to fill a DVD disc. Up and down respectively. The proton is composed of 2 up quarks and 1 down quark, while the neutron is composed of 1 up and 2 down quarks. You can check to see that the charges of the quarks add up correctly. Up and down quarks are said to be 2 different quark flavors. Because the quarks have half-integral spin, like electrons and neutrinos. There cannot be 2 identical quarks that have the same quantum properties. Quarks have additional property called color charge that can be red, green, or blue. A proton or neutron must have quarks with one of each of the colors so that they add to white. Just like ordinary colors do.
What is bronze?
An alloy of copper and tin.
What is the Standard Model?
The description of all the particles described below is called the Standard Model. A model is something like a theory in that it is intended to explain observations. But it is not as complete as a theory. The Standard Model works very well, but there are still many questions about it. Some of these will be explained below.
When are fusion reactors expected to generate electricity?
No one knows, but the prediction of scientists working on fusion projects that has been made every year since the 1960s is about 40 years from now.
What is a capacitor?
Device that consists of 2 conducting plates with opposite charge separated by an insulator to store electric charge.
What is Carnot efficiency?
Largest efficiency that a heat machine can obtain. E equals, thought, cold, / thought. Cathode negative electrode or terminal on, E. G a battery, electrolytic cell, or cathode ray tube.
Are there antiquarks like there are antineutrinos and anti-electrons, positrons?
Yes, there are anti-up quarks with charge -2/3 and anti-down quarks with charge 1/3. An antiproton is composed of 2 anti-up and 1 anti-down quarks. Antiquarks have color charges that are the complementary colors to red, green, and blue, cyan, anti-red, magenta, anti-green, and yellow, anti-blue. An up, or down, quark and an anti-up, or anti-down quark will annihilate each other, resulting in energy being released.
What is an atomic number?
Number of protons in the nucleus and thus the nuclear charge.
What is atmospheric physics?
Study of the atmosphere of Earth and other planets, especially effects of global warming and climate change.
Why do physicists believe that there are particles inside protons and neutrons?
Ernest Rutherford, 1871 to 1937, scattered alpha particles off gold atoms and discovered that the atom was not filled with a uniform positive material. In the same way, scattering of protons at high energies off hydrogen nuclei showed that the proton is not composed of uniform positive material. Rather, it is composed of three much smaller charged particles called quarks. The neutron is also composed of three quarks.
What is an apparent weightlessness?
Occurs when an object is in free fall. Force on object in direction opposite gravity is zero.
What is an anode?
Positive electrode or terminal on, e.g. a battery, electrolytic cell, or cathode ray tube.
What is a center of gravity?
Depends on how weight of extended object is distributed. The object's motion is the same as that of a point object in which the gravitational force that acts on its center of gravity.
What is a center of gravity?
Depends on how weight of extended object is distributed. The object's motion is the same as that of a point object in which the gravitational force that acts on its center of gravity.
What is a center of mass?
Because the force of gravity is proportional to the mass. The center of mass is at the same location as the center of gravity.
What is a center of mass?
Because the force of gravity is proportional to the mass. The center of mass is at the same location as the center of gravity.
What is the centrifugal force?
A pseudo-force that exists only in rotating reference frames. Apparent force outward from center of rotation.
What is the centrifugal force?
A pseudo-force that exists only in rotating reference frames. Apparent force outward from center of rotation.
What is a centripetal acceleration?
Acceleration due to a centripetal force toward the center of a circle.
What is a centripetal acceleration?
Acceleration due to a centripetal force toward the center of a circle.
What is the centripetal force?
Force that keeps an object moving in a circle. Must be exerted by an external agent.
What is the centripetal force?
Force that keeps an object moving in a circle. Must be exerted by an external agent.
What is the charge of electron?
E equals minus 1.602 x 1019 c.
What is the charge of electron?
E equals minus 1.602 x 1019 c.
What is a charging by contact?
Results when a neutral object touches a charged object.
What is a charging by contact?
Results when a neutral object touches a charged object.
What is a charging by induction?
Results when a conductor is first polarized by a charged object that doesn't touch it. Then one polarity of charge is removed from conductor.
What is a charging by induction?
Results when a conductor is first polarized by a charged object that doesn't touch it. Then one polarity of charge is removed from conductor.
What is the chemical energy?
Potential energy of a system due to its chemical composition. A chemical change can cause this energy to be changed into or out of other forms. Animal bodies and batteries are two common objects that have chemical energy.
What is the chemical energy?
Potential energy of a system due to its chemical composition. A chemical change can cause this energy to be changed into or out of other forms. Animal bodies and batteries are two common objects that have chemical energy.
What is chemical physics?
Study of the physical causes of chemical reactions between atoms and molecules and how light can be used to understand and cause these reactions.
What is chemical physics?
Study of the physical causes of chemical reactions between atoms and molecules and how light can be used to understand and cause these reactions.
What is a chromatic aberration?
Defect of a lens that introduces colors into images.
What is a chromatic aberration?
Defect of a lens that introduces colors into images.
What is a circuit?
Circular path through which charge can flow. Needs a source of potential difference, wires, and a device with resistance.
What is a circuit?
Circular path through which charge can flow. Needs a source of potential difference, wires, and a device with resistance.
What is the centrifugal force?
A pseudo-force that exists only in rotating reference frames. Apparent force outward from center of rotation.
Are protons and neutrons the only particles containing up and down quarks?
In the 1950s, new particles with masses in between those of the electron and the proton were found. They were given the name mesotrons, where meso meant intermediate. This was soon shortened to meson. The most commonly produced meson in particle accelerators is the pi meson or pion. Pions can be positively or negatively charged or unchanged arged. In the quark model, mesons are composed of a quark and an antiquark. It is also possible to create particles with different combinations of 3 up and down quarks. These particles have higher masses than protons and neutrons and can only be created by colliding protons and neutrons together with very high energies. Examples are the combinations UUU with charge +2 and the DDD with charge -1. These particles decay via the strong interaction. The UUU decays when its extra energy creates a pair. The D quark replaces one U quark in the UUU particle, resulting in a proton, and the 5 combines with the extra U quark to form At+.
Do electrons and neutrinos interact with quarks and gluons?
Electrons and neutrinos are called leptons, meaning a lightweight particle. They don't participate in the strong interaction, so they don't interact directly with quarks and gluons. They are, however, involved in the weak interaction through 2 additional force carrier particles. The W and Z bosons that can interact with quarks. Beta decay involves neutrons, protons, electrons, and neutrinos.
How is it explained using quarks?
Beta decay involves 2 steps. First, the down quark changes to an up quark with the emission of a W boson. Then, almost instantaneously, the W changes into an electron and antineutrino. Physicists diagram the 2 beta decay processes this way. When a nucleus undergoes beta decay, the number of neutrons goes down by 1. The number of protons goes up by 1, and an electron and antineutrino are emitted. In terms of quarks and leptons, one of the down quarks in the neutron is changed to an up quark in the proton. And a lepton, electron, and antilepton, antineutrino, are emitted. The change from down to up quark is a flavor change, and that can occur only in beta decay. When a positron is emitted in inverse beta decay, an up quark in the proton is changed to a down quark in the neutrino, and a lepton, neutrino, and antilepton, positron, are emitted.
What is the evidence that neutrinos have mass?
The number of neutrinos detected from the Sun is only a fraction of what should be detected if our understanding of the nuclear reactions in the Sun is correct. A proposed solution to this problem is that neutrinos change from one flavor to another on their travel from the Sun to Earth. This phenomenon is called neutrino oscillation. It can only occur if the neutrinos have a small mass. Most experiments that support neutrino oscillation measure the lack of neutrinos of one flavor that they interpret as an oscillation into an undetected flavor. Recently, an experiment has detected tau neutrinos in a muon neutrino beam from an accelerator at CERN and a detector 732 kilometers away, in the Gran Sasso tunnel in Italy. This flavor change supports neutrino oscillation.
How are neutrinos detected?
Neutrinos hardly interact at all with matter. Some 100 trillion pass through your body every second. Yet the chance that one interacts in your body over your lifetime is only 1 in 4. For this reason, neutrino detectors must be huge and can expect to detect only an extremely small fraction of the neutrinos striking them. Most detectors are large cavities filled with extremely pure water or mineral oil. Neutrino interactions result in flashes of light that are seen by sensitive phototubes. The detectors have identified neutrinos from the Sun, from cosmic rays, a supernova, and from reactors and particle detectors. Some experiments have used beams of neutrinos that are aimed through Earth by a reactor or accelerator at a distant detector.
What is an audion?
A vacuum tube amplifier invented in 1906 by Lee de Forest.
What is a beta decay?
Type of radioactive decay where nucleus emits a beta particle. Electron, from the change of a neutron into a proton. Antineutrino also emitted. Result is nucleus with same atomic mass number but atomic number increased by 1.
What is the origin of the masses of the quarks and leptons?
Peter Higgs, 1929, a British physicist, proposed a mechanism that gives rise to the masses of the quarks, leptons, and the two weak interaction bosons, the W and Z. The mechanism successfully predicted the mass of the Z boson. But it requires the existence of a particle, called the Higgs boson. Despite many searches, the Higgs boson has not yet been discovered. Physicists hope that the Large Hadron Collider, LHC, that started operation in 2010 will accelerate protons to high enough energies that the Higgs will be found.
What is a center of gravity?
Depends on how weight of extended object is distributed. The object's motion is the same as that of a point object in which the gravitational force that acts on its center of gravity.
What is the charge of electron?
E equals minus 1.602 x 1019 c.
How does gravity fit into the Standard Model?
It does not fit. Gravity, explained by Einstein's general theory of relativity, is extremely successful on the macroscopic scale. But, all attempts to create a quantum gravity have failed. So have attempts to fit gravity into the Standard Model.
What is a center of mass?
Because the force of gravity is proportional to the mass. The center of mass is at the same location as the center of gravity.
What is a barometer?
Device to measure gas pressure.
What is a Bernoulli effect?
One of three causes of lift. Due to difference in air pressure on upper and lower surfaces of wing.
What is the chemical energy?
Potential energy of a system due to its chemical composition. A chemical change can cause this energy to be changed into or out of other forms. Animal bodies and batteries are two common objects that have chemical energy.
What is the boiling point?
Temperature at which pressure of the water vapor equals the atmospheric pressure.
What is a circuit?
Circular path through which charge can flow. Needs a source of potential difference, wires, and a device with resistance.
What is a charging by contact?
Results when a neutral object touches a charged object.
What is the Bohr model?
A nuclear model but with electrons moving in only certain allowed orbits at discrete radii and with specific energies. When in these orbits their radii and energies are constant, the atoms do not emit or absorb radiation. Electrons gain or lose energy when they jump from one allowed orbit to another. Then they emit or absorb light with a frequency given by hf equals E2. E1 where E2 and E1 are the energies of the electrons in the allowed orbits.
What is a chromatic aberration?
Defect of a lens that introduces colors into images.
What are the masses of the quarks and leptons?
Because quarks can't be separated, their masses can only be found by using one or more theories to calculate them. The masses of the charged leptons can be measured to high precision. In the standard model, neutrinos are all massless. But recent experimental results demand that they have mass. Masses are given in a unit that is energy divided by the speed of light squared based on Einstein's E equals mc2.
What are force carriers?
The photon is called the force carrier for the electromagnetic interaction. That means that, for example, the attractive force between two oppositely charged objects is described mathematically not by an electric field, but by an exchange of invisible photons. The photon has neither mass nor charge, but does have angular momentum. The gluon carries the color force which, in combination with quarks, creates the strong force. The gluon also has neither mass nor charge. The weak nuclear force is carried by the massive W+, W', and Z degree particles. Gravity is carried by a massless particle called the graviton.
What is a block and tackle?
Simple machine that is a combination of fixed and movable pulleys.
What is a charging by induction?
Results when a conductor is first polarized by a charged object that doesn't touch it. Then one polarity of charge is removed from conductor.
What is a Bose-Einstein condensate?
Quantum effects on a macroscopic scale exhibited by extremely cold gas. Of atoms. Boson particles like photons and gluons with integral spin.
Are there yet more quarks and leptons?
There are two more generations of both quarks and leptons. In the second generation the quarks are called strange and charm. The strange quark was named after particles that contain these quarks. The particles decayed in very different ways and were therefore called strange particles. The charm quark was found in a particle that had a very long, or charmed life. The leptons are the muon and muon neutrino. The muon was first called the mu meson before its true identity was discovered. In the third generation the quarks are called bottom and top. The leptons are called tau and the tau neutrino.
What is biophysics?
Study of the physical interactions of biological molecules.
What is black?
The absence or the absorption of all light.
What is chemical physics?
Study of the physical causes of chemical reactions between atoms and molecules and how light can be used to understand and cause these reactions.
What are atoms?
Smallest piece into which an element can be divided and retain its properties.
Do the masses of the quarks add up to the mass of the proton?
The mass of two up quarks and one down quark sum to 8.81 MeV/C2, and gluons are massless. But the proton's mass is 938 MeV/C2. How can that be? The remainder of the mass is due to the high energies of the quarks and gluons within the proton.
What are beta particles?
Electrons emitted at high energy by some radioactive nuclei.
Can quarks be free, or are they always bound in the proton or neutron?
There have been many searches for free quarks, but they have never been observed. The theory that describes the interactions between quarks and gluons. Quantum chromodynamics, QCD for short, says that quarks can never break free because the more that the gluons are stretched, the stronger the force they exert. In this way they act like springs whose force also increases the more they are stretched.
What is a centripetal acceleration?
Acceleration due to a centripetal force toward the center of a circle.
What is the centripetal force?
Force that keeps an object moving in a circle. Must be exerted by an external agent.
What is an open circuit?
Circuit that is open so no charges flow.
What is an open circuit?
Circuit that is open so no charges flow.
What is the code division multiple access, CDMA?
Method of sending cell phone calls in which 3 calls are packed together with 6 more calls at 2 other frequencies.
What is the code division multiple access, CDMA?
Method of sending cell phone calls in which 3 calls are packed together with 6 more calls at 2 other frequencies.
What is the coefficient of friction?
Friction force divided by normal force.
What is the coefficient of friction?
Friction force divided by normal force.
What is the coefficient of kinetic friction Mk?
Coefficient when there is relative motion between the two surfaces. Smaller than static friction.
What is the coefficient of kinetic friction Mk?
Coefficient when there is relative motion between the two surfaces. Smaller than static friction.
What is the coefficient of static friction Ms?
Coefficient when there is no relative motion between the two surfaces.
What is the coefficient of static friction Ms?
Coefficient when there is no relative motion between the two surfaces.
What is color blindness?
An inability to see some colors due to an inherited condition.
What is color blindness?
An inability to see some colors due to an inherited condition.
What is additive color mixing?
Combining blue, green, and red light to form other colors.
What is additive color mixing?
Combining blue, green, and red light to form other colors.
What is subtractive color mixing?
Combining dyes, pigments, or other objects that absorb and reflect light.
What is subtractive color mixing?
Combining dyes, pigments, or other objects that absorb and reflect light.
What is colorimetry?
Measurement of the intensity of particular wavelengths of light.
What is colorimetry?
Measurement of the intensity of particular wavelengths of light.
What are complementary colors?
Pair of one secondary and one primary color that form what is close to white light.
What are complementary colors?
Pair of one secondary and one primary color that form what is close to white light.
What are primary colors?
Blue, green, and red of light, cyan, magenta, and yellow of pigments.
What are primary colors?
Blue, green, and red of light, cyan, magenta, and yellow of pigments.
What are secondary colors?
Cyan, magenta, and yellow of light, blue, green, and red of pigments.
What are secondary colors?
Cyan, magenta, and yellow of light, blue, green, and red of pigments.
What is brass?
An alloy that is typically 80% to 90% copper with zinc.
What are primary colors?
Blue, green, and red of light, cyan, magenta, and yellow of pigments.
What is a Celsius scale?
Temperature scale on which the freezing point of water is 0 degrees Celsius and the boiling point 100 degrees Celsius.
What are complementary colors?
Pair of one secondary and one primary color that form what is close to white light.
What is bronze?
An alloy of copper and tin.
What is Carnot efficiency?
Largest efficiency that a heat machine can obtain. E equals, thought, cold, / thought. Cathode negative electrode or terminal on, E. G a battery, electrolytic cell, or cathode ray tube.
What is accuracy?
How correct or how close to the accepted result or standard a measurement or calculation has been.
What is dark energy?
For the first 10 billion years of the existence of the universe, the attractive forces of gravity on matter, both ordinary and dark, slowed the expansion of the universe. But beginning about 5 billion years ago, the universe began to expand at an increasing rate. Two studies of supernovae have documented this acceleration. The cause of this expansion has been called dark energy, but the nature of dark energy is totally unknown. It interacts only via gravity and is very dilute. One possibility is that Einstein's general relativity has to be modified by the addition of a cosmological constant. Einstein himself considered such a constant, then discarded it, calling it his biggest blunder. The problem with such a constant is that particle physics estimates the value, in proper units, of 1. But the value required to explain the extra expansion is 10^120. This huge discrepancy cannot be explained.
What are possible replacements or additions to the Standard Model?
One proposed replacement is called supersymmetry. Each boson in the Standard Model has a supersymmetric fermion partner particle, or sparticle. And each fermion has a supersymmetric boson particle. They are called leptons, quarks, gluonios, and photons. These sparticles must be much more massive than the Standard Model particles. At least 480 billion electron volts. At this time there is no direct evidence of their existence. Although the LHC might be able to reach high enough energies to find them. A second replacement is string theory. String theory requires a 10-dimensional spacetime rather than the normal 4-dimensional spacetime. 3 spatial dimensions and 1 time dimension. A string is a tiny closed loop, like a rubber band. In some theories the loop can break into an open length, like a piece of yarn, but in others it cannot. Strings vibrate at characteristic frequencies, like guitar strings. Each vibration frequency corresponds to an elementary particle. If a string theory is to include fermions, quarks and leptons, supersymmetry must exist. The great advantage of string theory is that the graviton The particle that carries the gravitational force is naturally accommodated. But, if string theory is to be a theory of quantum gravity, then the size of a string must be the size of the so-called Planck length, 1.6 x 10 to 35 m. That is an unimaginably small length, 10 to 20 as large as a proton. String theories, however, contain symmetries that make their effects felt at larger distances. At this time there is no experiment that could test string theory. If supersymmetric particles are found, then string theory may garner more support.